Good morning. Today we're going to talk about graphs and charts. And one of the first things that we looked at was the scale of the universe. And what I found to be most profound is Halley's Comet. You can see it from Earth with the human eye, which to me is strange because when you think about things out in our galaxy, you would think that you would need a telescope and things like that. But for Halley's Comet, you do not. You can see it with the human eye, like I said, and it's visible every 75 years. The smallest thing that the human eye is able to see without assistance of a magnifying glass or microscope is the human egg, and California is larger than Halley's Comet, which was profound in finding as well, because you would think that a comet would be larger than one of our 50 states, but California and Texas are huge, and um, they're just really big in size, California and Texas. It's important to have a reference point when comparing measurements. The point of reference would be based on the perspective in which field you're in and what data you are comparing. So for example, in the scale of the universe, we compared on a meter system, and the human was about 3 meters in comparison to a 1 meter basketball. So we can see in the data is also being written in scientific form. See right here. We have 10 to the fourth 0.1, so that's about where Halley's Comet lies, is 10 to the fourth power, which is 10,000 meters was the size of Halley's Comet in on this scale that we looked at. And California was 100 million meters. And and the human egg was 10 to the negative fourth power because it's small, so it's getting smaller. If you think about it on a number scale, as we go to the right, we're getting larger. As we go to the left, we're getting smaller. So it's the same thing when we do the exponents. If we have negative exponent, we're going to get smaller. And the human egg is 0.0001 meters. And so we write in scientific notation because it's tedious, it's long-winded to say that Halley's Comet is 10,000 meters when I can just say Halley's Comet is 10 to the fourth power meters in size. So now we also watched, so this was the comparison of the scale of the universe, and like I said, I just found it profound that Halley's Comet is smaller than California. We also watched a video that Nassim talked about the speed in which your hand would be moving from point A to Z, which he says is a simple high school physics problem. I don't know. I didn't take physics in high school, and I don't plan on taking physics now. My husband studies physics, and he loves it, and he talks to me about it a lot, and I try to understand it. And this video actually got me excited, and I want to watch the whole thing with my husband so that I can understand a little more what he is talking to me about and showing me when he's doing his homework, because it is another language to me. All right, now Hassim says that if we're just trying to find the movement from point A to Z, we're not being true to physics because we must add the velocity of the Earth's rotation, and then with the orbit of the sun, and then the solar system. And so we have all these galaxies and all these things that we really have to add in their rotation to our movement. He says that we're constantly updating our world, our data in it. And to me, that was pretty neat. So just now, what I'm feeding you, we're updating. We're constantly updating. So we consume energy with our movements, and we create energy with our movements, which is kind of neat to me to think about the natural energy that we could use here instead of having to create this man-made electricity, so that we can preserve this earth a little bit for our future children. All right, and then so we also wanted to know, so we would have to add all these things in to know how how fast our hand was moving. And the Earth's rotation is 1,037 miles per hour. And if we were standing on the equator, that would be our speed as well. And to find that out, we estimate the hours in a day, which is 24 hours in a day, and then we divide that by the equator circumference. And our speed is 1,037 miles per hour, just as the Earth's rotation is when you're standing on the equator. And you don't move as fast at other latitudes on Earth. And so that's kind of, I thought, interesting. And so when you're on the equator, you are one with the Earth. You're moving at the Earth's rotation. And so you can see this from this graph, that the Earth has the slowest rotation. And over here on this chart, you can see that it is the lowest, and the local group moves the fastest. And so that's what we learned from Hasim's video. Right, down in Module 2, we talked about graphs that can be misleading or misrepresent their information. Here on this first graph, we talked about unemployment rate during Clinton and Bush's administration. On this graph, it looks extreme that unemployment during Clinton's administration was outrageous, and Bush had much lower unemployment rates. But what they've done is they've tricked us. They've put their y-axis, they've started at 0.02, and so it's made this look like there's a huge gap in between it. When if you set the y-axis at 0, you can see that there's really not much difference. Companies and even politics would do this to make their product look better, or their candidate for the campaign to look better, that they're stronger at their job, or their product is better, and it's really just not true. So you need to make sure that you're studying up on whatever product you're going to purchase. If it's a big purchase and you're looking at graphs like this, make sure that you understand it. You've done the math. Is the y-axis started at 0? All these things you would want to look at. Even here, deceiving in the bowling chart, Diana has 120, Hildy has 113, Emily has 127, and over here, Emily looks like she's, going over 130. When you set the y-axis at 0, they're all very close. They had a challenging game there. So make sure that you're looking at your graphs and fully understanding what you're reading there, what's going on. This arena funding, going the wrong way. The arena funding graph is also this kind of the same. It's deceiving in the city has given a very large portion, $265 million, to this arena funding, and they're split half and half with these other 3 contributors. When you really do an accurate pie chart, they take more than half because they've contributed more than half. So let's be fair to people when we're doing these kinds of things. Let's give them the credit that they deserve. Same here with Katira. Okay, they've put themselves in the middle to make it look like there's some grand distributor. They hold precedence over the rest of these companies when they've contributed the least. It's misleading. It's deceitful. Make sure you're looking at these things so that you're not going with a company that appears to be better than the rest and they're not. I know I've been a victim to bad companies before because their logos look cool, and I haven't really looked at things. So make sure to look at things. Don't be gullible and naive, because things can be misleading. Like for instance, I was looking up online the other day the crime statistics for Coralville, Oregon, because we're probably going to transfer there for a bachelor's degree. And at first, the crime rate looks really high. You're like, oh my goodness, we can't take our family there. This crime rate's really high. But then when you start comparing it to the other cities, it's really comparable. And um, also, when you start looking at the police logs, the arrests are misdemeanors. They're drunk and disorderly. It's a college town. You know, those are petty white collar crimes, and I'm not worried about those things going on. So again, just make sure you're looking at your charts. They are misleading. If they have not started their y-axis on 0, it's going to look like there's a huge difference in the data when it's honestly not. It's really close in comparable size with numbers. Down here on number 3, we talked about Americans and their health issues, and they have really gotten high over the years. Our obesity, our type 2 diabetes, our high blood pressure, they are really important factors in the health world, because they can be maintained. That is something that you can work on. Sometimes you cannot help having one of these. Diabetes are genetic. Obesity, if you have thyroid issues, you gain weight, and there's not really a lot you can do. High blood pressure can be genetic, but sometimes there are things that you can do to keep from getting these things. These demographics are based on 100% of the population, which is the total of 326 million. This sample data is to explain the dangers of health risk and the probability of having one or more of these conditions based on being diagnosed with a partnering condition. To take this data and incorporate it into a Venn diagram, we took this data and put it into a Venn diagram. So you had to take like the total of obese, the total of the people with type 2 diabetes, and the people with obesity. And in some formulas we added, in some formulas we subtracted, because you only had 1 or 2 of the conditions. So you can see down here, 10 million people are like, I keep going the wrong way. 10 million people out of 326 million have obesity, 3.1%. 0.3 million have type 2 diabetes, 0.1%. 23.3 million have high blood pressure. And a lot of this can be caused from the obesity and the foods that we eat, and not exercising. Exercising is, it's just such an important thing. Even it doesn't have to be high impact. Just get out there and get moving. It'll make you feel better. Oh, this didn't go over here. All right, and so then this just shows you your percents. 3.1 million would have obesity and type 2 diabetes. 52.5 million would have obesity and high blood pressure, because again, they kind of sometimes go hand in hand together. Sometimes it's hard not to have 2. When you have one, it's easier to have a condition that goes with it. Am I making sense? I'm not a health person. Give me crime, I'll talk to you crime all day. But these types of things are difficult for me, and so I'm trying to relate them to you. So again, if you have one, it is likely that you will have a paired ailment with it. And so here it just explains how we found that out. Like I said, in some formulas we had to subtract out the high blood pressure because we were only looking for obesity and type 2 diabetes, or we were only looking for type 2 diabetes and high blood pressure, so to subtract the obesity out and so forth. So if we live in different areas of our country, we also have a better percentage or a higher percentage of having some of these conditions. For some reason, Arkansas, Louisiana, Mississippi, you're higher for obesity. I don't know why that is. I have lived in Mississippi and now live in Arkansas. And prior to Mississippi and Arkansas, I lived in Florida for my whole life for 34 years. And I'm only 36 now. So I lived in Florida for a long time, and they're kind of comparable with everybody else. They're like in the orange to yellow field, which is a lot of the East Coast. But Mississippi, Arkansas, Louisiana, they're purple. They're the highest for obesity. And man, I just don't understand why that is, especially Arkansas, because I mean, I guess I think about here and think about being able to get out. So you think about the food, maybe. I would think that more landlocked countries, states would have higher obesity because you can't get the fresh fish, things like that. So that's really interesting. And then when you look at high blood pressure, those also change where you live. I think that your environment definitely could have something to do with these things. We know that your diet has something to do with them. And so what foods are offered? Are you able to get fresh fruits and veggies where you live? If not, what do you do about that? How can the health world help those states? Because that's terrible to think that you can't go live somewhere because you're going to be more prone to have obesity or high blood pressure or type 2 diabetes. I guess at the end of the day, it's really up to you, though. So that's these charts. And those are the Venn diagrams. So that was fun to do. Down here on Module 4, we did box and whisker charts. This was about heights of Army recruits, and we did these in inches. And this was just random mall shoppers in inches. And so here you had your range, your standard deviation, your coefficient of variations, and this is the information you use to graph these on your box charts. And then down here on your whisker charts, the trend lines are so light, and I tried to darken them, but I couldn't figure it out. So maybe I'll be able to figure them out as the semester goes on, figure out how to make those darker so you can see. So over here on the Army recruits, their standard deviation is much smaller than the random mall shoppers. Their standard deviation is only 4, where their standard deviation is 14. Excuse me. That's going to be because if you think about Army recruits, you probably have about the same size, height, and build of a person going in to be in the Army, where when you have a random mall shoppers, excuse me, you have kids, men, women, all different types of demographics that you're measuring. So your standard deviation, the difference in their heights, is going to be bigger here. Excuse me, I am so sorry. Excuse me. And so that's what these trend lines are talking about here. They're larger, they're wider. The deviation is bigger than over here with the Army recruits. When we come down here to the whisker plot, sorry, forgive me. To me, these look like TVs. That's how I don't know what they look like to me. And so the information It's just plotted differently, and it shows, hello, hello. Okay, well, it plots them differently than the graphs above it, and it shows you the numbers down on the bottom. Did I not put any data in here? Oh, I need to go back and put in data. Okay, wait. Value 70, series point. So it's showing you their inches, and it's just formatted differently. I like these better. I like the little dots and the lines. Let's see. The coefficient of variation is the ratio of the standard deviation to the mean. And so we've taken these to find the coefficient and the standard deviation. All right, down here on number 5, there was a study on Duke scholars and their sleep patterns. And they took a total of 217 Duke scholars, and their mean, they took all of their numbers of hours and added them up and divided them to find their mean, and that was 6.7. So they all roughly get close to 6.7, which is here, 34.1% of the total number was 217. So 34.1% of them sleep around 6.7, and they had a standard deviation, which that means they all deviated from each other about 2.03 hours. So college students don't get a lot of sleep. If you look at my sleep number, we are about 5.5 hours a night. Lots of nights I go to bed around 12, and we get up between 5:30 and 6. But the last couple of nights, I've been going to bed about 2 and getting up at 6. So I've been over here about at 4 hours of sleep. And studies show that if you miss one night of sleep, it takes 4 days to get your full brain function back. So we try not to miss a whole night of sleep. We try to at least lay down and get a little rest in between the kids and the homework. And we know that it's just a season, and that hard work pays off. But so college students get between, let's see, where is my data? Okay, so when we're recording this data, the mean never changes. So the 6.7 never changes, and we have that here on our graph. And then we have our standard deviation, and so we're adding 1, we're adding 2, adding 3, adding 4, taking 1 away, taking 2, 3, so forth. And then this shows you what those deviations are. Okay, so some get 8.73, some 10.76, some get less at 4.67. So we're either adding or subtracting, if you will, because when it's negative and you have a positive and negative, you end up subtracting. And so this graph right here is showing you that, and that's what we've charted here. And this is our deviations. And we've
Baby,
okay, baby. And here's some of those numbers as well, if we just kept going. And it's neat that Excel does a lot of this for you. This is a chart that shows our income. All right, let me look at my notes, I'm sorry. In the household income chart, the data is unproportionate. The lower income families are over here on the left, and it's just taking up a really small amount. Just like over here, the highest income is tailed over here to the right. It's just unproportionate. They're skewed right, making a tail, and the outliers, which are the low income and the high income, they really take up I shouldn't say they take up, they really are what the graph should be representing, because they are the higher data, the higher income. They represent more. If you get what I'm saying, they represent more of a total, the higher and the lower income, where these average, they have it just out so much, and this is not proportionate. Down here, I never knew that Elon Musk sold flamethrowers, and the first data, okay, I'll be right there. The first data entry of the white energy. Okay, come on. I'm sorry. Okay, I hope we're recording again. So I never knew Elon Musk sold flamethrowers. And the first data entry here shows you at a negative 12,000. On the y-intercept, you can see that here. It's in the middle of negative 15,000 and 5,000. And it just represents a large, sorry, a small portion here. And the reason it's down here and it doesn't look like, some terrible losses, because they eventually did make a profit. And they started making a profit right around here when he sold 220 flamethrowers before he ever broke even. And he had to sell 260 flamethrowers in order to make $90,000. And this is where they hit rock bottom, though. And so what's happened is it was negative 12,000 rock bottom. But because they made a profit, we can put that here. And so he did come out on top. And I believe that I might be reading this wrong, but so he had to sell 220 to break even. And then I think on top of that, he had to sell 260 to make it 90,000. So it's not like he sold 220 and broke even and then only sold like 40 more and made $90,000. But I'm not good at math, so I haven't figured that out. And so I'm probably wrong. But it's hard to start a business, Elon Musk talks about, and it's only the people who are diligent and stay with it who ever make a profit. My sister and brother-in-law own and run their own security business in Florida, and it's taken them a lot of years to get to where they are now. And there's even seasons like right now, they're not selling a lot of security systems because it was just Christmas. People don't have a lot of money, and so they're just having to send out thank you cards to their customers and just reiterating why those people want to be with their business. And so that would be tough. It takes a lot of work to start a business, to go under, it seems like, in a business, and to continue on, to say, nope, this is a good product. We're going to just keep on, because we are eventually going to make a profit. And $90,000 is a good profit to start with. And so that was neat to see Elon Musk. I've again watched some things on him briefly with my husband. He is really into Elon Musk. Dr. Robinette will tell you that she can't go anywhere with my husband to a PTK function without the mention of Elon Musk. So in this video, we talked about the charts and graphs and whatnot. So here on Elon Musk, we've taken this profit data and put it onto a chart to see how maybe a business venture would look on a graph. Here we've taken our household incomes and put them on a graph, and they're just so unproportionate. We have, I think that we have much more lower income families than this average of income. I mean, it's saying here that our mean is 49,000 average of how much money people make. And that's represented here, and then it goes up and then drops off like a cliff. And I don't know, where we're from in Pensacola, the cost of living isn't a lot, and it's taken my mom years to get here, and she has a college education and whatnot. But she's close to retirement, and maybe just making this much money now after 20 years just in that department. So, and then again, our hours of sleep and our deviation between sleep, and that's really neat to see how to do that. And then here's our bell curve here. I didn't talk about that at all at first. Our bell curve, it goes way up and then and down, and then only a little people get this much sleep. That's way too much sleep. Too much sleep isn't good for you either. So you have a big rise here where your mean is, because a lot of people fall under this bracket. So it has to, the bell curve has to go up. So I didn't mention that before. Here's our data about our Army recruits and our random shoppers, and our plots and our trend lines and our whisker plots, the Venn diagrams that show us the combinations of obesity and type 2 diabetes and high blood pressure. So here's in our millions, here's over in our percents, which way you like to look at things. I think this graph is supposed to be up here. Ooh. To show you how things need to be proportionate. 3.14, that's your radius. And unemployment, the misrepresented graphs that start their axis on a different number than 0 to mislead you, to make numbers look way unproportionate. And then this was all about having points of reference to measure by, and our movement of speed and the scale of the universe. That was really neat and interesting to learn. So I hope that this video was informative and you could understand what I was talking about. It was a little hard. I've never had to talk about math before, to explain it, especially in this type of format. So maybe what I've written here in my boxes will make a little more sense than what I've spoken. I'm not very eloquent with it, but I hope you guys have a great day. Miss Benzie, thank you so much for your time, and you have a great day. Thank you very much.